In 2007, the Town Commission of Lauderdale by the Sea in Broward County, Florida, unanimously approved an artificial reef using Biorock technology to be constructed. Spearheaded by Dan and Stephanie Clark of the non-profit organization Cry of the Water and championed by former Town Commissioner Mark Firth, this project would be the first coral restoration project using Biorock technology in the United States and the only one in the world using solar-powered buoys. The goal of the project was to create a world-class coral reef community and tropical fish habitat for the town of Lauderdale by the Sea. The Biorock technology and project construction would be provided by Global Coral Reef Alliance, under the leadership of President Dr. Tom Garreau, the former Senior Scientific Affairs Officer at the United Nations Center for Science and Technology for Development. Global Coral Reef Alliance is a non-profit organization that consists of volunteer scientists, environmentalists, divers, and other like-minded organizations that are dedicated to growing, restoring, protecting, and managing coral reef ecosystems. Global Coral Reef Alliance entered into contract with the town of Lauderdale by the Sea in 2007 to begin work on the coral reef fisheries and restoration project. In 2010, Vonnie Research was brought on board to assist with the installation, maintenance, and monitoring of the artificial reef. Vonnie Research of Pompano Beach, Florida, is a non-profit organization comprised of highly skilled volunteer scuba divers that work together to ensure conservation and preservation of Florida's oceanic resources. Vonnie Research was founded in 1989 by President Stephen Attis, whose passion is diving to make a difference. The Biorock technology mimics the natural growth of coral reefs and was invented by a pioneering architect, the late Professor Wolf Hilberts, in the 1970s as a way of growing natural building materials in the sea. In the 1980s, Professor Hilberts began working with Dr. Tom Garreau, a preeminent coral reef specialist, to use the Biorock process to restore coral reefs. Since then, hundreds of Biorock coral reef restoration projects have been built in more than 20 countries. As a result, Biorock reefs have kept corals alive in places where they would have perished, and allowed new reefs to be grown back in a few years in damaged areas. Two yellow buoys mark the location of the Biorock Artificial Reef Project, which is located just off the Datura Avenue Portal, a popular public beach access for snorkeling and diving south of the fishing pier at the end of Commercial Boulevard in Lauderdale by the Sea. After securing all the permits and approvals needed from multiple local, county, state, and federal agencies, installation of the Biorock Artificial Reef Project began on September 3, 2011. Once the Vonnie Research vessel was on site, 6 rebar structures weighing 90 pounds each and measuring 6 feet in length and 4 feet in width were lowered into the water. Lift bags were utilized to assist the divers in positioning the rebar structures on the ocean floor. 3 structures in a northern location and 3 in a southern location a short distance away. The rebar structures were placed end to end to increase their stability. Drilling holes in the sea bottom for the legs of the rebar proved to be a challenge. A 3/8-inch air-powered drill was used first but was insufficient. Switching to a 1/2-inch air-powered impact wrench with a drill attachment worked well. Each 1-inch hole was drilled approximately 14 inches into the substrate. 2 anodes with titanium cores are utilized in the Biorock project, one in the north structure and one in the south structure. Just like a battery, a solar cell has 2 terminals that need to be connected for current to flow through a circuit. The anode is the positive terminal and the rebar metal is the negative terminal, and a trickle electrical current flows through the water between them. With the Biorock technology, the seawater is the conductor that allows the electrical current to flow from one terminal to the other. When the wiring was hooked up, it was amazing to witness calcium carbonate forming almost immediately on the metal surfaces of the rebar structures. Portland cement was used to permanently attach the metal structures to the sea floor. Prior to cementing and to ensure good bonding, compressed air was used to blow out any debris that had settled into the pre-drilled holes. In accordance with the permits issued for the project, both Biorock reef structures and 4 reference sites are required to be monitored on a monthly and then quarterly basis. The reference sites are 6 by 6 feet squares located adjacent to the north structure and 15, 30 and 60 feet away. This was accomplished by building a movable 6-foot PVC square divided into 4 quadrants. 3 datums were placed into the ocean floor, 1 in the center and 2 in corner points to ensure accurate positioning for the monitoring requirements. Pilot holes were drilled into the substrate, and then an air-powered impact wrench was utilized to screw the lag into the substrate. The original buoy design had raised solar panels to allow for waves to safely pass over the buoy and under the solar panels. Vonnie Research invited local high school students to participate in the Biorock project to ensure that the younger generation would learn stewardship in protecting oceanic resources. Once the first buoy was attached to the rear of the research vessel, it was ready for deployment. On September 18, 2011, the first buoy was deployed, but the deployment operation proved to be no small task. By the end of September 2011, both of the Biorock reef structures were under full power, but this operational success was short-lived. On October 7, 2011, the south buoy flipped over in rough seas. The Vonnie Research diving team immediately sprung into action to right the overturned buoy. Extra mooring lines were added to secure the system. In the days that followed, the seas continued to build and both solar panels were destroyed. The original buoy design had failed. On October 11, 2011, when it was safe to enter the ocean, Vonnie Research organized a beach dive assisted by the Lauderdale by the Sea Volunteer Fire Department to bring both buoys ashore and to search for any debris from the solar panels. Vonnie Research divers were happy to report that there was no damage to the reef from the solar panel destruction. An engineering team led by the Vice President of Vonnie Research, the late Dr. Ray McAllister, examined the flawed buoy design and came up with several enhancements to make the system more durable and stable in the ocean. A solid stainless steel box with a Lexan polycarbonate cover was designed to house and protect the solar panel. The entire assembly was lowered to sit directly atop the buoy at a slight angle to lower the center of gravity. The counterweight was lowered 2 feet to increase the stability of the buoys in the water. The newly designed south buoy was redesigned